Techniques 1 and 2 do not involve lifting the house. As a result, they leave the lower part of the walls exposed to flooding. Masonry walls are highly resistant to flood damage, but wood frame walls are not. Usually, a house with wood frame walls is lifted above the flood level, and new masonry or concrete foundation walls are built below it, as in Technique 3. Now we can take a closer look at each of the 3 techniques. The first technique, extending the house walls vertically and raising the lowest floor, is usually appropriate when the flood level is no more than 4 or 5 feet above the ground around the house. The elevation process begins with the removal of the roof and roof framing in a single piece if possible. This is commonly done with a crane. The roof is then stored on site so that it can be reinstalled later. The next step is to remove the windows. Once the roof and windows are removed, several courses of concrete block are added to the tops of the existing walls and to the bottoms of the window openings. A corresponding number of blocks is removed from the tops of the window openings so that the size of the windows will remain the same. In addition, although not shown here, concrete bond beams are formed in place at the tops of the extended walls to provide structural reinforcement. Blocks are removed from the walls of the house at selected locations within 1 foot of the ground. The resulting openings will allow flood waters to flow in and out of the lower area of the house so that the water pressure on both sides of the wall will be the same. The roof and windows are then replaced, and a new wood frame floor is constructed above the flood level. A homeowner who chooses this technique may decide to build a new concrete slab floor instead of a wood floor. If so, compacted fill dirt or gravel is placed on top of the old slab, and the new slab floor is poured on top. Because the area below the floor is filled with dirt or gravel, wall openings are not required. When the flood level is more than 4 or 5 feet above the ground, the homeowner will usually find it more practical to add an entire second story to the house. The lower area of the house is then converted to non-habitable space to be used only for parking, storage, or access to the upper story. As in Technique 1, the repair begins with the removal of the roof and roof framing. After the roof is removed, construction of the new second story begins. First, a new wood-framed floor is built on top of the existing lower story walls. The second story walls are framed with metal or wood studs and set in place on the floor. Some homeowners prefer that the second story be constructed of masonry, but wood or metal framing is more common, primarily because it's lighter and less expensive. The roof is replaced, and blocks are removed from the walls to allow floodwaters to enter and exit. Exterior sheathing is then added to the framed walls of the second story. The new windows are installed, and siding or stucco is applied to the sheathing. Technique 3 can be used for houses with wood frame or masonry walls and is appropriate for a wide range of flood levels. Technique 3 is very different from Techniques 1 and 2. Here, the entire house, including its slab floor, is lifted above the flood level, and new masonry foundation walls are built below it. The most common method for lifting the house is to place metal I-beams below the slab and raise the house with jacks. First, trenches are dug to expose foundation walls immediately below the slab. Holes are then cut in the foundation walls at intervals around the house, and tunnels are dug under the slab. Jacks are placed in the trenches, and large I-beams are inserted through the tunnels and allowed to rest on the jacks. Smaller I-beams are then inserted through the tunnels at right angles to the larger beams and positioned on top of them. The smaller beams support the slab when the house is raised. The house is then jacked up. When the jacks have extended as far as possible, the house must be supported temporarily while the jacks are raised. Both the house and the jacks are usually supported on cribbing, temporary piles of crisscross timbers. The jacks are then used to raise the house higher. This process is repeated until the house is raised to the desired height. The foundation walls are then extended with additional rows of concrete block. Gaps left in the wall around the beams are filled later. When the extended foundation walls are complete, the jacks and beams are removed, and the openings left around the beams are filled with blocks. As in the previous techniques, openings are made in the walls within 1 foot of the ground, so that flood waters will be able to flow in and out of the area of the house below the elevated floor.